A new standard feature of the 2004 Savannah and Express 15 passenger vans is the addition of a vehicle stability enhancement system. Called StabiliTrack, this system incorporates sensors to monitor yaw, steering wheel angle, and brake and throttle positions to determine vehicle stability. For example, in an oversteer situation, the brake for the wheel on the outside of the steering arc is pulsed to nudge the vehicle back on track. In an understeer situation, the brake on the inside of the arc is pulsed. In addition, a traction control system is part of the StabiliTrack system. Traction control limits wheel spin by reducing engine power to the wheels and by applying brakes to each rear wheel as necessary.
What we do is we position sensors throughout the vehicle and we measure things such as steering wheel angle and individual tire vehicle speeds hundreds of times a second. We feed that information to an onboard computer and we call this GM system StabiliTrack. If a driver is steering a vehicle through a curve in the road, the system senses that and it predicts the actual path the driver intends to take. We compare that to onboard sensors which calculate the actual vehicle path. When the predicted path and the driver's intended path are the same, all is well and no interventions required. However, if the vehicle travels over a patch of ice or loose gravel, slippery road surfaces, the system senses that and it takes immediate action. It will automatically apply the appropriate brake and reduce engine power to correct the vehicle path and return it to the driver's intended path.
The new suspension on 2002 Escalade features an advanced StabiliTrack system incorporating real-time damping. The system is similar in operation to the electronic suspension control systems on other Cadillac models and uses components that you're probably familiar with.
Components of the StabiliTrack system with real-time damping include a suspension control module, a compressor leveling module, a pressure sensor, an exhaust solenoid, and a compressor motor relay. Then there's the steering wheel speed and position sensor, also referred to as the hand wheel speed and position sensor. There's also an electronic variable orifice solenoid, shock solenoid valves, and position sensors.
The objective of the suspension control module is to provide ride and handling that are superior to a passive damping system, both on and off-road under all load conditions.
The suspension control module monitors body-to-wheel height, vehicle speed, steering wheel position and speed, lift and dive status, and input status from a driver tow-haul switch in real time and instantly selects a normal or firm mode. This is done for each of the front and rear shock absorbers to adjust the vehicle for specific road and driving conditions. The suspension control module monitors the rear body-to-wheel displacements and vehicle speed inputs and uses the data to keep the rear trim height of the vehicle at its desired level. This in turn optimizes suspension geometry, headlight aiming, ride travel, and keeps the vehicle visually level. The system utilizes the compressor motor relay and the compressor leveling module, which contains the exhaust solenoid, pressure sensor, and compressor motor.